Binary logistic regression with one categorical predictor or one ordinal predictor in JAMOVI. Binary logistic regression with categorical predictor in JAMOVI. Binary logistic regression is a statistical method that can be performed to find out whether there is a relationship between two variables. One of the variable is called the outcome or the response variable or the dependent variable, and the other variable is the predictor variable or the exposure variable or the independent variable or the explanatory variable. For binary logistic regression, we need two variables. One of the variable is the outcome and the other one is the predictor. The outcome have to be binary. Binary mean that it have two levels in it. Whether you have a disease, no diseases, smoker, non-smoker, have diabetes, no diabetes. The predictor can be a continuous variable that is measured at interval or ratio level. It can be binary variable that consists of two categories, or it can be nominal variable, which is called categorical variable that consists of more than two categories or three categories and more. So it has to be either more than two categories or at least three categories to be called a nominal or multinomial predictor. And the predictor could be also ordinal, which is a categorical variable but with order in it. So the objective of performing binary logistic regression is to find out whether there is a relationship between the predictor and the outcome, and whether the predictor can explain the variation in the outcome. Here in JAMOVI datasheet, I had inserted 200 cases as shown in this window. There are two variables. The first one is smoking and the second one is cancer. So the smoking variable is categorical variable as it has four levels in it. The first level is non-smoker. The second level is smoking cigar. The third level is the smoking pipe. The fourth level is smoking cigarette. So there are four categories in this variable. So it is categorical variable or multinomial variable or nominal variable. It's all the same meaning. The second variable, which is cancer, is binary or binomial because it has only two levels in it, either yes or no, whether they have the cancer or no cancer. So here we have an outcome which is binary, cancer, and a predictor which is multinomial, which is smoking. To find out whether there is association between smoking and possibility or probability or likelihood or chances of developing cancer, then binary logistic regression can be performed. The test depend on the outcome that have to be binary, and the condition is satisfied here. So we have outcome which is binary and a predictor which is categorical. Before we proceed and do the binary regression, let's look at some descriptive statistics by clicking on the exploration here and then tick on descriptive. In the new window here, drag the smoking to the variable section or variable sections and the cancer to the same box, and then tick on the frequency tables here. And for statistics, since we have both variables are made up of or consist of categories, then we don't need the median, we don't need the mean. For the dispersion, we don't need standard deviation, and we'll keep the rest. Looking at the output here in the descriptive, the first table shows that there are 200 cases and no missing cases. in both variable. For smoking, the minimum value is 0. 0 is assigned for those who do not smoke, and 3 for those who are in the last category, which is cigarette smoking. So 0 for no smoking, 1 for cigar smoking, 2 for pipe smoking, and 3 for cigarette smoking. The second table shows the frequencies. There are 50 cases in each category for the smoking habit. For the third table, it shows the frequencies of cancer. There are 100 cases of cancer, and there are another 100 of cases of not having cancer. To find out whether there is association between smoking and cancer, then we need to do binary logistic regression. To do that, click on regression here, and then scroll down to the two outcome binomial regression test in the new window here. Drag the cancer, which is the outcome, into the dependent variable. Drag the smoking, since it is categories, drag it into the factors, since it has 4 levels in it. There are a few options to select from here. Model builder, no need to select anything. For reference levels, since we have here two categorical variables, the cancer and the smoking, the reference category will be used is the no, those who do not have cancer. So comparison will be to the individual with no cancer. For smoking, there are 4 levels. We can select any of these as a reference group to compare to. We'll stick with the non-smoker as a reference group. Assumption check or checks, not look at it at this stage. For model fit, tick on the Cox Snells and tick on the next one for R square. And for a model coefficient, select the odds ratio here and the 95% confidence interval. For the estimated marginal mean, no selection. For the prediction, again, probably classification table, but we'll not look at it at this stage. Looking at the output from the binary or binomial logistic regression test, there are multiple tables produced. The first table is for the model fit measures. Looking at this value here, which is the R square, it shows that 11.7% of the variation in the outcome can be explained by smoking habit, whether you are a smoker or non-smoker, smoking cigar, cigarette, and pipe. So 11.7% of the variation can be explained, variation in the outcome, which is possibility of getting cancer, can be explained by smoking. Moving to the second table, which is a very important table for model coefficient with the outcome, which is cancer. Again, predictor here is given. Intercept, we will not talk about intercept in this section. For smoking, there are 3 categories. All of them has been compared to non-smoker. So cigar is compared to non-smoker, pipe is to non-smoker, and cigarette to non-smoker. Looking at the footnotes here, those who have cancer given yes, and those who have no cancer no. So cancer, here we are looking at possibility of developing cancer. The estimate is given for each output, which is the coefficient, the standard error, z-score, the p-value, the odds ratio, and 95% confidence interval for the odds ratio. Here we have 2 levels of significance to check the significance, the p-value and the 95% confidence interval. P-value will be set at less than 0.05, and anything less than 0.05, then this significant. Here is shown that all the 3 categories, there is a significant association between smoking and developing cancer. and for the 95% confidence interval, all the odds ratio fit within the lower and the upper limit for the confidence interval. So from this table, there is a significant association between the predictor and the outcome. The way to interpret this table is that those who smoke cigar have an increased odds of 2.7 compared to non-smoker. Or in another way, those who smoke cigar have a higher chances of developing cancer, or more likely to develop cancer. For the second category, which is pipe compared to non-smoker, those who smoke pipe have an increased odds of 2.5 compared to non-smoker. So smoking pipe increases the probability of developing cancer. For cigarette category, those who smoke cigarette have the highest likely of developing cancer compared to non-smoker, as the odds is 6. So there is an increased chances or increased likelihood of developing cancer with smoking any type of tobacco here. Those who smoke a cigarette have the highest chances of developing cancer. So this is the way to perform binary logistic regression with an outcome that is binary and a predictor that is categorical in JAMOVI. Binary logistic regression with ordinal predictor in JAMOVI. Here in JAMOVI datasheet, I had inserted 200 cases, and there are two variables. The first one is the age category, the second one is diabetes. So the diabetes is a binary variable because it has only two levels in it, whether you have diabetes or no diabetes. Age, though age is continuous, but here it is classes or categories. Category from 16 years old to 24, and then the second category is from 25 to 45. The third one is from 46 to 70, and the fourth one is greater than 70 years old. So there are 4 categories here, youngest one to the oldest one, though it is age, but it is in category and there is order in it, youngest, older. So this is a ordinal variable. It is categorical, but it is ordinal, more precisely ordinal, as it has order in it. So to find out whether there is association or relationship between the age category and the diabetes, and whether this predictor, which is the age category, can predict possibility of getting diabetes, or the outcome, which is diabetes, variation in it can be explained by the age categories, then binary logistic regression can be used, as the outcome here, which is diabetes, is binary and the predictor is ordinal. Before we proceed to the regression, let's look at some descriptive statistics. Click on exploration and then select descriptive, then drag the age category into the variables, the diabetes into the variables, tick on the frequency tables. Let's get rid of, since both of them are categories, we don't need the mean and the median. We remove the standard deviation, we keep the minimum and the maximum. From the output for the descriptive analysis, there are 200 cases. So both variable, there are 200 cases and no missing cases as shown here. The age category is assigned values 0, 1, 2, 3. The 0 assigned for the age category from 16 to 24. The value 1 assigned for 25 to 45, and value 2 assigned for 46 to 70, and 3 for anything greater than 70 years old. The second table shows the frequencies in each category. So as we have 4 categories here, there are 50 individual or cases in each category. For the binary outcome, which is a diabetes, there are 81 cases of those who have diabetes and 119 without diabetes. So those who do not have diabetes have a higher proportion. To do binary logistic regression, click on regression, scroll down to the 2 outcome binomial. Since this or these data fit perfectly to the binary logistic regression. In this window, diabetes is our outcome, so we'll move it to the dependent variable. And since the age categories is factors, we'll keep it into the factors. We could move it to covariate, but we'll keep it here into the factors, and the age category is best fit here. Let's select some of the options here. We'll click on the reference levels. Since we have here 2 variables, both of them have categories in it. The diabetes have either you have diabetes or yes or no. No will be used as a reference category to compare to. Age category, which is from 16 to 24 years old, will be used as a reference category to compare to. Moving to the, I'm going to skip the assumption checks. Moving to the model fit, tick on the Cox and Snell's R Square and the other R Squares. For model coefficient, I'm going to tick on the odds ratio and the 95% confidence interval. For estimated margin, no selection. For prediction, no selection at this stage. Looking at the output here, we have 2 important tables. The first table is for model fit measures. Looking at the R square here, it shows that a value of 0.255. This value means that 25.5% of the variation in the outcome, which is diabetes, can be explained by the predictor, which is the age categories. Moving to the second table, which is the model coefficient for diabetes, we used those who with no diabetes group as a reference group. And for a predictor, which is the age categories, all the 3 are compared to the reference category, which is 16 to 24. So this is the reference category here. In the table, we're going to ignore the intercept, and looking at the footnote here, it says that the odds of diabetes for yes and no. Values here is estimate for the coefficient, the standard error, the z-score, the p-value, the odds ratio, and the 95% confidence interval. So there are 2 levels here for checking significance. P-value, any p-value less than 0.05 will be considered as significant, and 95% confidence interval, when the odds ratio fit between the upper and lower limit, then it is significant. So here from this output, we can see that there is a significant association between diabetes and the predictor, and even with each categories of the predictor. So there is association. The outcome, variation in the outcome in diabetes can be explained by the age category. So age is a factor that can explain whether you will have a chance, probability, likelihood to get diabetes. The way to interpret this table is that looking at the first category, for those individuals who are in the age range of 25 to 45 years old, have an increased 3.1 odds of having or developing diabetes compared to the younger generation, which is, or younger individual, 16 to 24. So older individuals have a higher chances or are more likely to develop diabetes than younger one. For the second category, which is from 46 to 70 years old, those individuals in that category have an increased 7.3 odds of developing diabetes compared to the younger group. So with increased age category, the odds increases. So that means the elder people have a higher likely chance of developing diabetes. Looking at the final category here, those who greater than 70 have the highest likely or chances of developing diabetes compared to the younger group from 16 to 24. And all these findings are significant. So this is the way to perform binary logistic regression with an ordinal predictor in JAMOVI. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clips, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, JAMOVI, R Statistics, GraphPad, Prism, GPower, Python, and RevMan. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, JAMOVI, R Statistics, GraphPad, Prism, RevMan, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.